Welcome to the tech review of the LCS Jet. We're going to get started just by doing a quick product demo. I'll show you how it switches on to the propulsion unit and how you take it off, and go through the whole process so you can see the user experience just from a high level. So we're going to start. We got a folding prop on the motor here right now. We're going to take that off, take the tail cone off, and we're going to put on the LCS Jet. So we'll start with our LCS system here. We pinch the two pins, pull that guy off. Now we're going to pinch the tail cone, slide him right off. We'll get our first look at the LCS Jet here. It's a sort of self-contained unit. When it's off, you've got the prop captured inside. To open it, we're going to depress the button and rotate the cone, and it'll come apart. The first thing we're going to put on is the shroud, and that just clips right on like that. The next thing we're going to do is the propeller, and this also has LCS system as well. You just pinch the pins, slide it right on, give it a little twist. And one note you'll want to take here is that you'll make sure the propeller blade is out of the way of the button, so that when we slide on the shroud, the button can move in and allow it to snap together. So we're going to do that now. We're going to take the shroud, we're going to take our white dots, line them up, push it on all the way, and then we'll just do a little turn to the right, and now it's locked on and ready to ride. So now that we're ready to go, maybe we're done, we're going to take it off. So it's the same process, just in reverse. We're going to press the button, rotate the shroud to the left, it's going to pop right off. Then we're going to come to the prop, find our LCS buttons, come in here and grab it. Oh, going to use this hand. This one's a little bit trickier than the other ones, just due to the location of the button. Pop that off, and then we're finally going to grab the two buttons here and pull off the shroud. And then for storage, what I like to do is put the propeller in here, and then just simply pop the cone back on, and now we got our unit stored, ready to go back into the bag, and we can put our open prop back on for some wave riding fun or some more advanced maneuvers. So that's how it goes on and off. And now we'll get into the meat of it, the technical review, materials, methods, and manufacturing details. So let's get to it. Okay, so let's take a look at a couple of the interesting design details of the LCS Jet. So I've got it put together here with the prop in the middle, and the first thing I'm going to show you guys is an interesting one that kind of sneaks under the radar, but it's a nice to have little safety tip, or for some people who are more safety conscious or not as familiar with the product. It's going to be this hole right here. You can actually take your wing Allen key and put it directly in there, and it will key into the propeller, and it allows you to rotate the propeller. So this is like I showed you in the assembly video. If your propeller is behind the button, it may not allow it to depress and release. So you can put the Allen key in there, and take a little bit and find the hex. There it is. And then you can rotate the propeller a little bit just to clear the button. All right, so with that, let's take it apart. Oop, there you go, it's in the wrong position. Right there. Let's take it apart, and I'm going to show you a couple of details about the propeller. So we're going to start just by comparing the size and the shape to the standard 3-blade. It's obviously a bit smaller than the standard 3-blade, and I'll just give you a little profile projection here so you can see. Give you a little profile projection here to show you the difference in the blade shape. It's basically truncated here on all the blades, but otherwise it's quite similar. And I would imagine the pitch is a bit steeper, given that it's going to be spinning a bit faster inside of the shroud. You'll need a bit different pitch. So here's kind of a view of the blades. And I'll give a quick little propeller diameter measurement. What we're going to do is measure the inside of the shroud, and that's pretty close. So you can see we get a little bit of rubbing in here, and that's totally normal. I can't feel these with my finger now. So it's just very light surface scratching, just to change the color a bit, and that's to be expected. You want the closest fit you can get to get the maximum performance out of the jet. So with the parts all being replaceable and, you know, interchangeable without tools, there is a limit to how close you can get, and it's right on the optimum. So if you see that, don't worry. It's totally normal as long as it's not making any really bad noises or melting. You'll be right in shape, just fine. So we're taking a measurement here. Just measure the inside of the cone, and we got 111.4. So you can presume the prop's around 110 to give you an idea of the size. All right, the next thing we're going to take a look at is the stator geometry, and that's this piece right here. This we'll call it grate or screen. What this does is it straightens out the water to recapture the swirling motion and turn that into propulsive force. So the nice thing about this LCS Jet compared to some others is that this is following the optimum CFD design. So there is actually twist in the blades. The ring here, which is for finger protection, is actually at an angle that is the same kind of angle that you would see here. So there's quite a bit of design detail that channels the water in the most efficient way to get the maximum performance out of the jet. Where, you know, on the bolt-on jet, you'll see that this is actually, it's molded into the cone, and it's parallel to the flow, so it doesn't have any twist or anything like that. Whereas the one on the LCS Jet is an upgrade, and it has additional shape, again, to match the optimum CFD and just kick that performance up to the next level. So that's a really nice feature on the LCS Jet. Super cool that they went above and beyond for that. So let's move over into the shroud piece and look at one of the other touch points, and that's the main button. So you see it has a diving board style spring to allow it to move, and it's a nice design touch. It's very simple, no moving parts, no assembly, and it works quite well. It's a bit stiff, but they balance the length so that it's tight, it doesn't feel loose, and it also has a nice click when you put everything together. I think it's one of my favorite things about this is when you rotate it, it has a nice click. Just kind of fun. And one other thing that goes along with that is that the rotate to lock geometry, which I just demoed there. So you'll see the shape in the shroud, the part on this side, there's like a gap here. You'll see here, there's one right there. This piece, it slides directly in, and then as you rotate it, it goes underneath, and there's a slight ramp there. So it jams it into position. And what's really nice about that is that it takes up all the tolerance and it creates a nice tight fit. So it really helps the cone and the shroud here fit together well, even when they are, you know, separate toollessly assembled pieces. And then the key design element of that is the rotational lock is handled by the button. So the button doesn't do any thrust force. It just makes sure that the cone doesn't unscrew. And so as long as the cone doesn't unscrew, all of that thrust, which is pushing on the stator and on the cone out the back, is going to be handled by these interlocking teeth. So it's using the large diameter, strong plastic material to hold the heavy load of the actual prop force, and using the button to do only one much simpler job and prevent the cone from rotating off. And it's also, you know, quite an intuitive, simple attachment method. I think we've all used some kind of twist lock in various products throughout our lives. So that's a couple interesting design features related to the shroud and the cone. And some other stuff I just wanted to show, like the attention to detail with this in terms of the fit, finish, and the feel. There's even things like little ramps here that help the button slide in, and just to show that this was dialed in pretty well. It wasn't sort of a slapdash job. You can see quite a few design details that show the passion that went into it. So very cool, just on the design features there. All right, well, now let's get into the meat of it. A little bit of engineering experience. We'll start talking about the materials that I see used in the product here. Now we're gonna start with the plastics. These are very clearly high performance engineering plastics. You can tell just by the stiffness, the way that they feel. They are not light duty, and there's quite a bit of glass in here as well. I would guess on the order of 40 or 50% glass fill. And that gives you a lot of stiffness and strength in the plastic. So it becomes, something that's just honestly mind-blowing in terms of the strength and stiffness. I've used quite a bit of this material in my personal career, so I have a pretty good respect for it, and it's something where if you design it well, it outperforms aluminum in terms of cost, manufacturability, and performance in some cases where you need the characteristics of the plastic are best suited to the application. So from my analysis here, I can say from experience, it's going to be some kind of semi-aromatic engineering plastic with 40 or 50% glass fill, and very likely some other characteristics such as low moisture uptake and just clearly a high strength and toughness factor to be handling all this abuse in the propeller system. So again, you can feel that they picked a good one. I have 100% confidence in it. Whether or not somebody calls it a plastic or a polymer or whatever, it's a good material. And this stuff is used throughout industry, automotive, aerospace, you name it, it's used everywhere. So it's great to see that they're leveraging those kinds of developed industries and supply chains and bringing all that technology and research down into the e-foil space. So that's fantastic. All right, so next let's talk about the metal. We're going to start with the silvers, and this is all 316 stainless. The buttons here, the tab itself, all these little metal pieces, the screws, and even down to the pins in the shroud here. It's all 316. It's pretty obvious just from having used it, and it's not rusting. And 304 even, you can tell, but 316 is the best stainless grade for general marine use and corrosion protection. So it's nice to see that that's what they're using for everything. It's definitely the premium choice. And I think the last material I saw in the product is aluminum. The stator here is actually anodized aluminum. It is not plastic, and it is CNC machined. So this is quite a high dollar fancy part, but it's sort of rounding out the trio of materials here, and it's anodized black, which again is a good choice for a saltwater and marine environment. All right, so we've looked at the design and the materials. Now let's take a look at the manufacturing methods for them. So one of the most obvious is the plastic or the engineering polymers. Those are going to be injection molded. Now this is another interesting part because of how complicated the geometry is on all three pieces. We'll start with the shroud. It looks simple at first, but these undercuts and other shapes and the hull require quite a few sliders inside to pull in as you do the molding. And then in addition, the tight clearances, that's another area where you need to have a very well dialed in molding process so that when it shrinks and all these other factors that affect how the final part comes out are well controlled across multiple batches, thousands of them. And it can be quite difficult. So I'm very impressed with how they were able to produce that with nice tight tolerances and good fit. Next, move over to the propeller, and this thing is quite interesting. It is it's again molded. They have quite a few slides to get the geometry in here. And one thing I noticed about it is when we're looking at this hex key, the sprue, so the leftover plastic in the mold, it's CNC machined away, and then they use that same operation to cut the hex. So this is again a CNC machine sprue is it's a more expensive option. Typically you would see it snapped off by hand or just cut with pliers. But in this case, having a nice smooth flat surface there, plus the hex called for that additional cost in getting it into a machine to have it taken off. So another interesting thing about the propeller, we'll take a standard LCS prop I've taken apart here, and we'll show you some inserts which are molded into the propeller. Now this is the same on the jet prop as far as the main insert. The screw holes are slightly different, but the principle is identical. The nice thing about these is while you say that they're plastic, the engineers focused on where the load was going through them, and they've inserted a 3/16 stainless kind of billet here and finish machined it. So this is going to take all of the thrust loading of the prop and put it through a piece of steel and distribute that well into the polymer. In addition, having it machined, it gives you a nice tight fit onto the motor shaft, and that's a huge benefit for wobble and vibration. So again, a nice detail touch on the engineering side to make sure the propeller fits well and runs smooth. And just having it as a co-molded part with the propeller, again, great for assembly, parts count, things like that. Just a great idea to simplify things and get a higher quality, more robust production for the propellers. So it would not surprise me if they were able to mold these and they're ready to go, balanced, and all that kind of thing. So fantastic detail on the propellers there. And then they just clip in the LCS mechanism on top. So quite a nice piece of engineering here. Let's move on to the shroud here. We'll look at this part from the injection molding standpoint. It is, again, not a simple part. It has got quite a bit of geometry that is off the main open-close axis, such as our diving board and the undercuts for the cone, the clips here. So I'm sure a lot of engineering went into this one, and it's, again, quite a detailed and nice plastic piece and made out of that nice resin. So great to see that they, again, well controlled the diameter, the position. All of these things are super critical where your tolerance is stacking up off of the motor face. So quite impressed with the molding on there as well. Now let's talk about the stainless steel 316. It's on the shroud and the propeller. Very clearly, every single one of these parts, except for the screws, is CNC machined. That's another very premium process that it just shows the commitment to the high quality and materials from Lift. It's used for production, and it's great to see. When you pay top dollar for these boards, you want to know that you're getting it. And on the hardware side, they have definitely delivered in that regard. And coming finally to the stator, made out of aluminum, this is sort of the apex of the quality and the commitment to performance from Lift. This is a fully CNC machined stator, and it's quite an intricate part. It needs to be done from both sides, and it has these very thin pieces on it, which need a hole mounted in the end for the pins. So the stator is dropped in from the back, and then it's pinned in. And each one of these vanes needs to have a hole drilled in the end. So it's quite a complicated part to machine, and I cannot imagine that it's cheap. So they really bucked up for top performance on this part, and it's incredible to see that it's the standard equipment for the Lift 5. I think it's fitting of a new model. It was really a premium item on the Lift 4, and it's showing its performance chops this year on the Lift 5. So I hope you guys enjoyed this kind of engineering overview of the LCS Jet, and I hope you learned a few things about it, about its details, materials, construction, and what makes it so special in terms of an engineering standpoint. The engineering team over at Lyft killed it with this one, and it's quite impressive. So you've seen a few competitors come out with a similar design, but I doubt that they have the same attention to detail in the materials and the construction that you will see here. Again, as a career engineer, this is a nice piece. Thanks for taking some time to go through the LCS Jet with me. I hope you enjoyed looking at the materials, the design, and some of the manufacturing methods that are used to make it possible, and also to see where the quality is in these parts and what it takes to really optimize the best performance. I'll be doing additional reviews of various Lyft products that I have and showing you some more design details. So if you're interested in that, please stick around, subscribe, and I will be posting those videos very soon. Cheers, guys.